Hi everyone. So we are going to discuss another interesting problem now in this binary search series, which is Painter's partition problem. So this problem has been asked in Google once, and it is quite interesting problem to discuss. So let's just, without wasting any time, let's see what this problem has to say. So in this problem, we are given n boards with length of each board. Right. So basically, and we can consider an array of size m in which each element of the array represents the length of the board. Now there are certain conditions. Like first is that uh, a painter takes t unit of time to paint 1 unit of board. So we are considering the length of the board as a unit. So for example, if the board is of length 5, which is provided as in the array, we can say that like it is of 5 units of length. Okay. So a painter takes t units of time to paint 1 unit of the board. So for each unit, painter will take some t unit of time, which will be given to us. Then second condition is that a board can be painted by only one painter. That means that for each board, we cannot assign or utilize two painters. Only one painter is going to paint at each and every board. Okay. A painter can only paint boards placed next to each other. So like that is continuous segments. What this means is that, for example, let's say if there is a painter who is painting this board with length 5 or 5 units of length of board, then after he or she is done with this painting this board, he can only move to the board just next to this, that is 3. He cannot directly jump to board number 1 or board number 6. He needs to consecutively paint each and every board. Okay, so painter can only paint the boards placed next to each other. So now what problem is asking us? Like I have divided it into two parts. First, we are going to discuss this part one because it is going to help us build up a certain base for the part two, which is going to be a very interesting problem. So, continue watching the video till the end because part one is just the base, which I'm going to build over the part two. Okay. So, what part one states is that find the minimum number of painters to paint all the boards in X unit of time. Okay. So, if we consider what is given to us in the problem, so we are given n boards. Let's say from the below, like we are given 5, 3, 6, 1, and 9. So these are the n boards. Okay, we will be provided t unit of time. Let's consider this for example 2. So what this 2 is stating is that it takes painter to it like for a painter who is working on a board, it takes 2 units of time to paint 1 unit of board. Okay, so for this length, we can say that if a painter P1 is assigned to board, let's just name this board as A, this board, okay, and this board as B, this board as C, D, E. Okay, just for easier reference. So if P1 or painter P1 is assigned to any one of this board, let's say a painter P1 is assigned to board A. Let me just toggle the size. Yeah. So painter P1 is assigned to board A. Okay. So if T is given to, then the time taken by the painter to paint this board will be 5 times 2, that is 10. Okay, because T is the unit of time to paint 1 unit of board, so 5 unit of board will be painted in 5 times 2, that is 10. Okay, then and we are also what we are given is the x unit of time. So this x is actually stating that this is a total amount of time which is like given to us. Let's just consider as 50. So we need to find that how many painters will be required to paint all the boards in 15 units of time. Okay, so we need to find the minimum number of painters. One thing is that if we assign each and every painter to each and every board, So we can say that the minimum five painters we can assign and they can paint all the boards. But we need to find the minimum number of boards, minimum number of painters. Okay, who can do the job in the given X units of time. Okay, so these are the things which are going to be given to us. So let's just consider one example, like as I provided here. Okay, so okay, right. So now we are given this, right? So let us just find out like how much time it does it actually take to paint each and every board. Okay, so for 5 unit of board, how much time will it take if p equals to 2? It will take approximately 10, not approximately, it will exactly take 10 units. And how will we find it in finding this? I just explained it. Like we just multiply it by uh, this is just basically 5 times 2, right? My network, sorry for the inconvenience, my network connection is quite slow. I'm not sure why. Uh, it's not working. Yeah, now it's back. Okay, so this is 5 times 2, right? Now for 3 units, we can say that the amount of time which is taken is 3 times 2, which is going to be what? 6. I'm just going to write it like the number only because again it is something chaotic happening here. Yeah, so I'm going to write 6 here, right? And then for this 6, I'm going to get what? It is going to be 6 times 2, that is 12 units of time, right? This is going to be 12. Then for 1, it is going to be 2. And then for 9, it is going to be 18, right? So this is the amount of time which is going to be taken if p is equals to 2. Okay, let me just format it so that it is quite clearly visible to everyone. Right. So if t is given us as 2, so this is the amount of time which is taken to paint each and every board, right? If t is equals to 2. Okay. So now we are provided that we need to paint all these boards in x is equal to 15 units of time. So one thing to observe here is that even if you would see here, let's say if we assign each and every board a single painter, here you can see to paint this particular board, it is actually taking 18 units of time, which is greater than the overall time which has been provided to us, right? So even if we assign a painter here, he will not won't be able to complete this board within this given time. So are we going to get any painters here who can do the job in x equals to 15 units of time? The answer is simple, no. So here we can return -1 or whatever it is, like you can return false, like no painters can be provided here who can do the job in this amount of time. Okay. Now let us consider another example. Let's just say that we are given uh, one more example. Okay. So let's just say x is equals to 30. Okay. Now when x equals to 30, now we can see that each and every board's individual time is very much less than 30. So we will be getting some answer here. We will be getting some minimum number of painters who can actually paint these boards in the given time. Okay. So how are you going to find this? Now let us consider this board 10, right? So for for this board A, which is of unit 5 units of length, right? Say close. For this board A, which is of 5 units of length, the amount of time taken is 10. So if I'm going to assign, right, hear me carefully here. So if I'm going to assign P1 painter to board A, okay, this is going to show me. So if I'm going to assign P1 painter, let's say painter is P1, I'm going to assign it to A. So the amount time taken by him is 10. Okay, so let me just do one thing here. Let me just put it like this. Right, time taken. I'm sorry, I'm not sure why this is happening, but it is always changing its font on its own. Yeah, so time taken is 10, and then I'm going to have the remaining time, right? Because we are given certain remaining time. So the remaining time is going to be like after 10 units of time has been taken by P1 painter, the remaining is 20. Now we can assign the same P1 painter to B, right? Because still we are having some remaining time. So let us just assign this to B1. So like if I am assigning painter P1 to B, right? So the B to paint the board B, it is taking 6 units of time. So here if I am going to write 6, so the remaining time now is going to be 14, right? Because total time taken is 16 and 30 minus 16 is 14. So I can go ahead still and assign the painter P1 to C, right? So how much amount of time is C like painter will take to complete the board C? That is 12, which is still less than the remaining time here, right? Here 10 was less than 30, so we can consider that P1 can utilize the board A and paint it. After he has done his work, the remaining time left would be 20. Now, for this board B, we saw that this 6 is again less than 20, so we again assign P1 to board B, right? And then the remaining time left is 14. And remember here, like if you observe, we are moving in a sequential manner, right? Because the painter can only paint boards placed next to each other in a continuous segment. So now we are moving in a continuous segment manner. So here, after painting B, the remaining time is 14. Now, when we move to C, right, when we are moving to C, what's this again? Yeah. So when we are moving to C, the amount of time taken by the painter, right, the amount of time taken by the painter is 12, which is again less than the remaining time. So we can say that painter will utilize this board C in painting, and the remaining time now will be 2. Okay. Now when we come to board D, right? So again, 2 is less than equal to the remaining time here, right? 2 is less than equal to the remaining time. So we can again utilize this P1 painter in painting our world board D, because we need to find the minimum number of painters. That's why we are only using the same painter again and again, right? Because we are having a time remaining here. So we are going to utilize the same painter again and again. So now when okay, is again trying to see if it is, yeah. So now in for D as well, the painter is going to take what? 2 units of time here. So now we are left with remaining time as 0. Now if we move to next mode, 18, our painter P1 cannot do the work because the time is over. But the point is that all these painters are going to work simultaneously. So we have observed here that painter P1 can paint all the boards A, B, C, and D in 30 units of time. So for the last board, we can say that we can assign a painter P2, oh, sorry, P2 for the last board E, and he can do the job in 18 units of time with time remaining as with the time remaining as 12. But yeah, again, yeah. So P1 painted all the boards from A, B, C, and D, and then P2 painted the board, last board E. So in total, how many painters did we utilize here? There were only 2 painters. So we can say here that for x equals to 30, only 2 painters were actually required here to paint all of these boards, this and this. So these painters are going to work simultaneously. You can say that painter P1 is working on board 5 and painter P2 is working on board E. And painter P1 will continue to paint all these boards. Meanwhile, painter 2 will continue to paint the board from here, E. Right. So in total, we utilized two painters to actually paint all of the boards. Okay. So I hope this dry run was enough to actually come up with some approach here. So you can pause the video and think about certain approach if you're getting. Then after this, I'm going to share a certain like the code which is going to work here. It is going to be a single loop and yeah, like a linear approach here and no extra space required. It is going to be very easy. So you can pause the video now and then think about the solution. Okay, so I hope you have thought of the solution and written it down. So I'm going to write the code here for your reference, like what is going to be. So let's just say that the painter count initially is one because we are going to utilize at least one painter to start with, right? And the time, which is time we can say provided, or let's just consider this as x, which has been provided to us, that is 30. Okay. Now we are given n boards, so let's just consider boards as five and what was it? 5, 3, 6, 1, and 9. Okay, so 5, 3, 6, 1, and 9. Okay, and we are given what else we are given? The t. So let's just consider t equals to 2. Okay, so for I in range or the board's length, so we know it is 5, so I'm going to just write 5. Okay, now if my board length. Now we what we did here was we calculated for each board, we calculated the amount of time it takes to paint that board, right? And we compared that time with the given time. That is what has been provided as x. If it was less than or equal to x, we keep on subtracting that time from x and we continued with the same painter in the loop. So that is exactly what we are going to do, right? So if my uh, time let's just say this time is representing the time to paint board. Okay, if this is less than given x, then we subtract it from x and continue with same painter, right? So the same painter, like we can say that we won't increment the painter count. The same painter is going to go do our work. So for boards I, if it is votes I times t, right? Because it is going to give us its time. So if that is less than or equal to, right? Or let's just do one thing, right? One of the conditions which we saw here, like for the board here, we saw that for board 9, since it was 18, it was again greater than 15. So we saw that we cannot assign any painter to this thing, right? So let's just handle that condition first. Okay, we can do that in the loop itself. We can just say that if at any time for my board I, okay, multiplied by t, if at any time it becomes way greater than my x, right? If it becomes way greater than the x given to us, the x that is basically the unit of time in to paint all the boards. If it is any time greater than that, then we can simply say that we cannot assign any painters. We can print -1 or anything which is required by the function and just break from them, right? Else, we can, what we can say is like, or we can do one thing more, like we can assign painters count as -1 and then break. So which will actually say that at the end the painters count is -1, stating that no painters can be assigned here. Else, we are checking the condition if the time is basically less than or equal to our x provided, right? So it will come part of the elif loop, I would say. Okay. So if at any time it is less than equal to this, so what we are going to do, we are going to subtract from x the time, right? So board I times t. right? So that amount of time we are going to subtract from x and we are going to continue. Or else, now the condition is that if it is not less than equal to, like if somehow it is not becoming less than equal to, in that situation, what we need to do, because it was like quite obvious here that after we assigned painter P1 to all these boards, our time became 0. Our x became 0. Now painter P1 cannot be assigned here. So it is going to hit that else condition here. So once that condition is hit, we assign a new painter. So we increment our painter count by 1, right? And this new painter is going to actually going to work on our new board. So our x is now going to be for this current board I, right? And the initial time which was given, let us just take this as time left, because we need to maintain this x actually here. So I'm just going to take this variable as time left. Okay. So here I'm going to consider as time left. Here I'm going to consider it as time left. And here I'm going to consider it as time left. Okay. So now time left is going to be boards times t, the amount of unit time taken to paint that board, and x minus that amount of time. Because the new painter is going to start, we can say that the painter which you're assigning is actually going to start from the simultaneously along with other painters, right? So he is going to start from 0 unit of time, or you can say x unit of time, like 0 unit of time. So x minus the current board, time taken to paint the current board, is going to be the remaining time for this new painter, right? And we continue. At the end of the day, what we do, we return the painters number. Cool. So let's just check this once, like if it is actually returning as the correct answer or not. Hmm, I'm not sure why it is taking so much of time. Let me just refresh it once. Yeah, below. But you got the concept, right? So this is the only going like this loop is in a single loop. We can actually determine how many painters are we going to utilize to paint each and every board. Okay. So this is going to be the single loop. Okay, this is saying problem connecting to this board server. That's interesting. Okay, just loaded. This is again paste that code here and try running this again. It is working quite slowly. But yeah, this code is actually going to work. I'm pretty much sure about this. So yeah, let me just move ahead with my other question. Right. So we saw this for minimum number of painters to paint all the boards in X unit of time. So whatever X unit of time we have been provided and whatever the board's length, we are able to calculate the number of minimum number of painters who can paint that board. Okay. Now let's move to the actual question which was actually asked in Google. Okay. The part two of this question is, find the minimum time to paint all the boards if P painters are provided. P painters are available. Like, so I know it is very like quite small change, but it is just reverted what we have asked earlier. Earlier we were provided the unit of time and we needed to find the number of painters to paint that board in that unit of time. Now we are provided with the painters. Okay, now P painters are available with us, and we need to find the minimum amount of time which each and every paint, like with these P painters, who like minimum amount of time all these P painters can paint all of these boards. In what amount of time all of these P painters can paint all of these boards? Okay, so that time we need to find, that is the minimum amount of time. Okay, I think this has loaded. Let me just run it once and see if it is working or not. Uh, yeah, so it worked. So it returned to us as 2, right? For x equals to 30, for time like t equals to 2, it returned us 2. Let us just check for 15 once. Like for 15, we saw that it was returning us -1 as the answer, right? Answer -1 because for 9 times 2 was 18, which was becoming greater than. So it is going to encounter this if block and it is going to return as painters count as -1. So let's just see. Mm, and it returned us -1, right? So this code is working fine. Okay, so now let's move to the next question, the next part which we are discussing. So we need to find the minimum time to paint all the boards if P painters are given, right? So what is the minimum time will be required to paint all of these boards if P painters are available to us? Now, one thing to observe here is that for the unit of time which is provided as to us as X, right? There can be a possibility, like we observe, like there can be possibility that we cannot assign any number of painters. Like for example, here, since to paint this board, it was exceeding the time itself, so we cannot assign any number of painters here for this total unit of time x equals to 15. But here, since we are provided p painters, we are always going to get a certain amount of time here. There won't be any condition because it is actually asking what is the time going to be if P painters are available. Right. So we are always going to get that time in which P painters can paint all of these boards. Okay. So this since this series is a binary search, so definitely this problem is going to be solved with binary search. In this part one, I have given you some basic idea of as to how to approach this problem. You can pause the video and think about how binary search can be applied now here to actually, find this answer. But I would suggest you to go with the brute force approach and then come up with the binary search. Right. So pause the video now and then think about the solution. Okay, so I hope you must have thought of something. Right now, I'm going to discuss how we are going to solve this problem actually with binary search. Okay, so thing is that in binary search we require two basic things. One is the target, like what actually we need to find, and one is the search space. The search space is going to provide us like in what area or what is going to be a search space in which we are going to discard a certain half of our problems and consider a certain half of our problem. Right. Binary search is also always about searching, right? So it works in a manner that whatever search space is provided to us, it discards a certain half of the search space and finds the answer in the other half of the search space. Okay. So what is the target going to be in this here? Like target is like what we actually need to find here. Let's see what we need to find here. Okay. So target is the minimum time. Right. That is quite sure from here. Like we need to find the minimum time to paint the all. Target is our minimum time. What is going to be the search space? See, search space is going to be eventually the time, right? Like we are going to consider a search space of time in which we are going to target the minimum time, in which P painters can be utilized to actually paint all the boards. Right. Search space is going to be of time itself, the units of time. Okay. In which we are going to find that minimum time, let's say X, for which P painters can be used to paint all the boards. So here we need to find that X here. Okay. So how are we going to find our search space? That is one interesting thing we need to figure out. Okay. So one thing we can observe from this problem is that let's just say that if we provide each and every board a single painter. Okay. If we provide each and every board a single painter, let us say that T is again given to us as 2, or let's just consider T is given to us as 1. That is, it takes 1 unit of time to take 1 unit length of a board. So for each and every board, the length which is given to us, right, that is going to be the time taken to paint these board as well. Considering just an example here, that is T equals to 1. Okay. So if I'm going to assign P1, P2, P3, P4, P5, like each and every painter for each and every board, right? So what is the minimum amount of time which will be taken by all these five painters, right? What is going to be the minimum time? Well, it is going to be equal to the length of the board, which is maximum amongst all these, right? Because once I assign each and every painter to each and every board, right? Painter P1 is going to complete his work in 5 minutes of time. Painter P2 is going to complete his work in 3 minutes of time. P3 in 6 units of time. P1, P4 in 1 unit of time. The most amount of time is taken by P5, which is 9. So in all, since we need to paint all the boards and we need to find the minimum time to paint all the boards, so all the boards will be eventually done after the maximum length board, right, is completed. That is 9, right? So for any T, we can say that the minimum amount of time, right, to paint all of these boards. Let me just write the statement once, right? So it becomes more clear. So for any T, right, if we consider n painters, each like one painter for each board, then the minimum, okay, sorry, I'm not sure why it is again and again disconnecting, although the network is fine. Uh, okay, so for any time t, we can say that each painter is going to work on one of the boards, and the maximum amount of time is taken is going to be equal to the length of the board, the maximum length of the board, right, which is 9 here, right? So then the time, the minimum time taken to paint all boards is equal to maximum length of board times t. That is the minimum time. Or let me see, minimum time, sorry, maximum length of board times t. Okay. Now this is one observation here. Now second observation is like if we don't consider like P1, P2, P3 and P4 and P5, like we don't consider one painter for each board, right? If we just consider for any T, if we are only having P1 or only having a painter P, only one painter is available with us, right, for any time T. So how much is the minimum, like what is going to be the minimum time to paint all the boards? It is quite easy, right? It is going to be the sum of all the boards multiplied by the total time T given to us, right? So the minimum time taken to paint all boards, if only one painter is available with us, is going to be sum of all board length multiplied by T, right? Here we considered maximum length of board times T, and here the sum of all the board length times T, right? So this is actually defining our search space here, if you observe. How come? Because ultimately we are going to be provided with certain P number of painters, right? If P is equal to 0, if no painter is available with us, then we can't find any time to paint all them, right? So P will be given to us. It will be going to be certain value, and it is always going to be greater than equal to 1. So we considered for P equals to 1, the amount of time taken is going to be sum of all boards, right? And what is the maximum value of P? See, if we are only given certain number of boards, like if you are given 5 number of boards, and if you are even having 100 painters, okay, but if you are having five boards and we are provided 100 painters, but out of those 100 painters, only five painters are going to be working on each and every board. Because as per the constraints, only one painter, like only a board can be painted by only one painter. Right. So even if we provided with hundreds of painters, the number of painters at max which are going to be utilized to paint the boards is going to be the length or the number of boards which are available to us. Right. So that's why I considered the number like the painters equal to the number of boards which are provided to us, and the amount of time in that situation is provided us with this equation. Yeah, maximum length of the board multiplied by t. So this is actually what like this is actually covering our scenario or covering our search space. It is covering the time. Right. It is actually defining what is going to be the minimum and the maximum time which can be utilized here. Right. So now this the minimum time this is the maximum time which is going to be taken. If only one painter is available, then we are going to paint all the boards. Maximum amount of time will be taken. Right. And to if we are having painters which are equal to the number of boards which are provided to us, then minimum amount of time is going to be taken to paint all the boards in that scenario. Like this is you can say the best case scenario that for each board we are having one painter. So ultimately the minimum amount of time is going to be taken that is equal to the maximum length of the board multiplied by t. And this is the worst case scenario that we are only having single painter. And so we need to add all the lengths of boards and multiply it by the time t which is provided to us. Okay, so this is actually covers our search space. Right. So our search space is going to vary from this maximum length of board times t and the sum of the boards. Now, once you've defined our search space, right, like you can say summation of boards times t to maximum length of board times t. Right. Once you have defined our search space, now you can clearly observe this that we are now provided with a certain units of time. Right. We are provided. You can consider this as an array of units of time ranging from summation of boards to maximum length of board. Right. This is ranging from this to this. Right. And this is an array of time. Now this problem statement, if you have observed carefully, this problem statement become exactly as above. Here also we were provided certain unit of time and we needed to find the number of painters to paint all the boards. See here also we are now having a certain range of time, right? We are having a certain range of time in which for each unit, for each time we need to find if we are having for that unit of time we are having p painters to paint that board, right? So this problem now became exactly same as the previous one. And now to find that thing, we are going to actually utilize the binary search to find that time or to find the number of painters. Right. So let's just see how binary search is going to be applied here. Okay. So now let me just remove this code from here. Okay. So now I'm going to write the code and then I'm going to explain it. We are going to do one small dry run as to how it is actually working. The code is very simple, right? I shouldn't have deleted everything. I should just delete it from this linear here. Okay, right. Now we know that our range is going to be like let's just consider as the minimum range that is going to be the maximum of these things multiplied by t, right? So minimum time is when we are having number of painters equal to the number of boards which are given to us. So in that situation we are going to get our best case answer, that is maximum length of board times t. So that is going to be a minimum, like that is going to define the minimum range time. So that is going to be maximum of boards QRDS times T. And our right, or the maximum range, or the maximum time limit that can go up to sum of all the modes times t. So let me just find the sum of all modes for like sum of modes equals 0 for value in modes, like sum of modes plus equals to value, right? So sum of modes times t, like now we are going to apply binary search here till the time my left is less than equal to right. Right. So what exactly is happening here is that left and right are actually defining the unit of time. So we are going to consider a range from maximum board time t, that is, you can say what in our scenario this is 9 times 2, which is equals to 18. We are considering a range from 18 to what? What is the summation of all the elements in this array? That is 5 plus 3, 8, 8 plus 6, 14, plus 1, 15, and plus 9, 15 plus 9, that is 24. So 24 times 2, and that is going to be 40, right? So this is the time range, like from 18 to 48 we are going to search. We are going to search for a mid, right? Because binary search is always search starts with search from the mid and discards a certain other half, right? So mid is going to be right minus left, oh sorry, right plus left by 2. Okay, so our mid is going to be right plus left by 2. Now, or let me just consider it in a worst case scenario to handle the edge cases. But plus right minus left. Okay. Now this mid is actually representing the unit of time. Now what we need to find? We need to find the number of painters, right? Which can be utilized for this mid unit of time to actually paint all the boards. So what we did was, for any time t, which was x, which was provided to us, what we were doing, we were actually doing the calculation in the linear loop here, right? For any, now for any x we were calculating with the linear approach here, the number of painters which were required. So I deleted the linear code here. I shouldn't have deleted that. So let me just do one thing. A simple thing here is that let me just copy it in my notepad, and let me just revert this and bring back that code. Right, so this was a linear, this was actually giving us the painter count. Let me just define this function, painter count. Right, this function is going to return me the painter count in linear time. Right, so I'm actually going to utilize this to find the number of painters which are for any x unit of time. Right, I'm going to return here painter count, and let me define the painter count here. Cool. Right, so this is going to return me my painter count. Now I can actually paste my code here, which is the binary search code. Right. So now count of painter is going to be painter count, which is going to get a mid. So here we are going to get some what we were considering as our time left. Okay, so let me just consider it as time left itself. So x is 30, so time left is always, or let me do one thing, sorry. So this is not time left, this is x provided to us. So time left is going to be equal to x itself, because this is the x within which we need to find the number of painters, right? What this x if we are having any painters, right? So this is the x and the time left we consider it inside that x. So yeah, this is now going to return us the painters count, right? Now once we have found this painter count, now we want this painter count to be equal to what? We want this to be equal to the painters provided to us, right? Because that painter count, once that painter count becomes equal to the painters we provided to us, we can say that the mid for which we were calculating this painter count is actually our answer, right? Because what we are actually eventually doing here, once we have defined our search space, right? Once we have defined our search space of time, that is the maximum length of board time t and the sum of both times t. So this units of time for each and every unit, you can say, or you can say that by binary search for every unit of time, we are calculating the count of painters, whether it is equal to the painters p, right? And once for a particular unit of time that is made, the painter count becomes equal to p. We can say that that is the minimum amount of time taken by the p painters to actually paint all the books. Okay. So here we will just compare, like if count of painter equals to p, which is provided to us, then we can simply return our answer as mid and break. Elif, if our count of painter is less than p, like now this is very important. Like if our count of painter is less than p, what needs to be done here? So what it is actually stating is that for any unit of time x, the number of painters which are required our is lesser, right? For any time x, the number of painters which are being used is less than the desired time. That means we need to increase our time so that our painters become more. It has an inverse relation, you can say. The time here and the number of painters. So as we increase our painters, right? As we increase our number of painters to paint the boards, the amount of time to take to paint all the boards will decrease, right? Observe this one thing. Let me just explain here. So if we increase the painters to paint boards, the time taken will decrease, right? And if we decrease the painter to paint boards, then time will increase. So there's an inverse relation here. So, but here what we need to do, we need for a time we are given the painters. So for that, if the painter count is less than the current, right? If the painter count is less, we need to increase the painter count. That means the time needs to decrease. And since the time needs to decrease, where we need to go? We need to go towards the left. That's why I'm going to decrement my right to mid minus 1. Right. So I'm going to discard my right half and I'm going to search in the left. That is towards the minimum time I'm going to search. Right. Again, let me just clear this once. So since if the count of painters are coming less than the desired amount of painter, right? If the count of painters are coming less than the desired amount of painter, so we need to actually increase our painter count, right? We need to actually increase our painter count. So to increase our painter count, what we observe here is that if to increase our painter count, we need to decrease the time, right? So how we are going to decrease the time? We need to in this array is by going towards the left. Okay, and how we go to left? We go to left by discarding the right half. That is right by mid minus 1. Else, it is quite easy now. Else, if our count of painter is greater than p, then eventually we need to decrease our painter count. That is, the time will need to be increased. So left will be equals to mid plus 1. And by this, we are actually going to calculate our answer. Let's say answer is 0. So we can eventually return our answer as here. So after this complete loop, we eventually come up with our answer. And for the minimum amount of time, if P painters are actually thrown. Okay. So let's just see. Okay, let's just see it like how this is going to work. So let's just say that P is given to us as 2. Okay. So we have already found here that for P equals to 2, no, yeah, P equals to 2, the unit of time was 30. But I'm not sure if it is the minimum time which will be taken. So let's see that if it is the minimum time, right? So for P equals to 30, let's see that what answer it is going to return us. Okay. So let me just run this once. And I'm hoping there are no syntactic errors here. Uh, answers. Answer is less than sum of modes are here and definition of intervals. Equals to equals to 2. Yeah. I'm not sure why it is taking so much of time to be loaded. Okay, let me just do again one thing, then copy this and refresh my browser again. And also I need to, I think, switch to my other network as well. Okay, sure. Yeah, we will. Yeah. Let's just see that if it works or not. It should be working now. Yeah, I eventually copied the code, so that's fine. So ultimately, I'm thinking like there are no syntax error at least here. So just copy this, paste it here, and then run this. Um, it's taking a lot more time than I expected. Okay, this is might be due to browser becoming very slow. But eventually, this is the way it is going to be done. Right? X is not defined. Okay, mode times t is greater than x. X is this small x which I consider? Okay, my bad. So I think I need to consider capital X here. Right. Let me just run this again. Okay, so it returned 33 to us. So, okay. So amount of time for P painters was minimum amount of time was 33. I think we might be doing something wrong here, or if my painter count is less than, so I'm going to search for it. Let me just consider a condition where I search for the most minimum time. So lower bound answer we need to find, right? So we can just say that my answer is eventually going to be mid, right? And let's see if it gives the correct answer as times. That is 28. Yeah, now I think it is given. So by what I did was that I just changed the condition here to find the lower bound answer. So till the time a count of painter is less than or equal to p, I stored that answer here in the mid and continued in the loop. Eventually, when my left or my complete array, you can say by binary traversals are done, the last answer is 28, which is what I'm going to do. Let's just see that if 28 is actually fitting our answer. So for P equals to 28, right? The number of painters which can be required here. So, oh, sorry, for T equals to 2, right? And for X equals to 28. Like we are just doing some dry run to check if this 28 is actually correct or not. So time taken by this was 10, right? 10, then 3, 6, then 6 twos are 12, then 2, then 18. So 28 after P1 painter is assigned to board A, or you can say board 5. So remaining time will be here, that is 18. Then after 6, it will become remaining time 12. Then at 12, it will become 0. Then again, we are going to utilize second painter, and yeah, it is coming fine, just fine. Right, so here 26, and then here 26 minus 18, that is going to be 8. So from here onwards, we are going to utilize our second painter to work on these boards. So yeah, this answer which is coming correctly. I just saw it through the diagram itself. So yeah, this is the overall code. Let's just discuss the time complexity here as well. Like what is the time and the space complexity. So space complexity is quite obvious that we are not taking any extra array here, right? We are just considering all the variables. So complexity is going to be big O of 1, right? And what is the time complexity here, if you would observe? So binary search itself is taking log n, right? It is discarding certain half of the search space and searching in other half. So it is taking us a log n, and this count of painters, this is actually a linear function, right? The painter count is actually linear function. So you can say that the overall time complexity after utilizing binary search to find the solution to this problem is n log n. And space complexity is big O of 1. So this was all for this question. I hope you understood most of the things here. I just request you to also go through this problem once again, or go through this video once again and try to solve this problem on your own, right? And understand it, because it was quite interesting problem. And just by utilizing binary search, we were able to solve this problem eventually, right? So I'm sorry for the inconvenience because the network connection was quite bad at my location. But I hope you learned something today, and thanks for watching.